So let's sum up the transformations that we have done, and this is in your notes. All right, so translate up or down. If C is positive, the function shifts up. All right, and if we add a negative value to the function, then the function shifts down. So if we have f of x and then minus c, we have a function and then we have we're subtracting a value, that function is going to shift down. Translating left and right, all right, f of x plus c, the graph is going to shift to the left. X minus c, the graph will shift right. So you see a positive sign, a plus in front of the c, and it's inside the grouping symbols, the graph shifts left. If you see a minus c inside the grouping symbols, where c is some constant, the graph is going to shift right. Alright, so here we have it already graphed, and we're going to talk about the transformations. So compare the graph of the function y equals the absolute value of x plus 2, and the y equals the absolute value of x. So y equals the absolute value of x is the parent function. Right? And so now we're going to describe how the graph was transformed. All right, so notice that if we compare points, here we have the point 0, 0, and we have a similar point, that vertex on the y equals the absolute value of x plus 2, and it's at 0, 2. So notice that the graph has shifted up 2. So number 1, the graph is shifted up 2. The domain is still negative infinity to infinity, but the range has changed to 2 to infinity because the graph's been shifted up 2. And you can add that to your notes. All right, the blue graph is y equals the absolute value of x. The green graph is y equals the absolute value of x minus 4. All right, the blue graph again has a point 0, 0. The green graph has a vertex at 0, negative 4. So here the graph is shifted down 4. The domain is still negative infinity to infinity, but now the range is negative 4 to infinity, and we would use brackets on both of those ranges. So in summary, when y equals the absolute value of x plus k, the graph is shifted up k units. And when we have y equals the absolute value of x minus k, the graph is shifted down k units. Here we have 2 more, and I think these are in your notes. I was trying to find, oh yeah, I grabbed the notes, and yep, this one's in your notes as well. All right, so we have y equals the absolute value of x plus 3, and y equals the absolute value of x. So now we can compare points again. On the parent graph, we have the point 0, 0. On the transformed graph, we have the point negative 3, 0. All right, so the graph is shifted 3 units left. There is no change, however, in the domain and range. That would be negative infinity to infinity for the domain, and 0 to infinity because we didn't shift up or down. All right, so again, we have y equals the absolute value of x goes as a vertex at 0, 0. Y equals the absolute value of x minus 2, where the minus 2 is inside the absolute value bars with the x, has a vertex of 0, 2. So notice that the graph is shifted 2 units right. The domain is negative infinity to infinity, and the range still 0 to infinity because we just shifted to the right. We didn't shift up or down. So when y equals the absolute value of x plus h, where it's inside the absolute value bars, and we're adding something to x, the graph is shifted h units left. When y equals the absolute value of x minus h, so the minus h is inside the absolute value bars, the graph is shifted h units right. All right, so minus is right, takes a larger value, plus is left. And we're going to go ahead and do this one, and I am going to give this one to you so you can put in your notes. And so you will have already gotten this, and I'm going to give you part of the table as well. Okay, I can move that a little bit. So I'm going to give you this much of the table. I'm going to give you the x. We're going to have a column, and then a y, and a column. And actually, I didn't think of doing that until this very moment. Oh, actually, you know what? I'll graph the parent graph too. So I'll go, and then I'm going to take a screenshot. All right, so hopefully it'll work. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. And then we square those numbers because the parent graph is y equals x. Actually, I have it written right here. A nice straight line. So negative 3 squared is 9, and then negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, and then 1, 4, and 9. And so let's go ahead and graph those. So 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, and negative 2, 4, and negative 1, 1, and 0. Wait, we've gotten offline here. We skipped a line, then 0, 0, then 1, 1, and 2, 4, and then 3, 9. So here's the parent graph. Let's see. Oh, you know what? I'll have to erase this anyway and do it in class. I'll take a screenshot after I've erased everything on this board except for that. All right, so now let's look at the translation. Now we have two translations. We have a horizontal translation and a vertical translation. So we're going to add or subtract the horizontal translation to the x and add or subtract the vertical translation to the y. The horizontal translation is x plus 2, so x plus 2 is left 2. So we're going to subtract 2 from all the x's. So negative 3 minus 2 would be negative 5. Negative 2 minus 2 is negative 4. negative 1 minus 2, negative 3, 0 minus 2, negative 2, 1 minus 2, negative 1, and so forth, and 0, and 3 minus 2 is 1. All right, so we've got the horizontal. The vertical is what's added to the whole function. So the vertical is minus 3. Notice it's added to the whole function. It's, actually we could write it like this, or subtracted to the whole function. G of x minus 3. So we're going to subtract 3's from all the y's. 5 minus 3 is negative 8. Negative 4 minus 3 is negative 7. Negative 3 minus 3 is negative 6. Oh, wait, sorry. Ignore that. I guess I'm getting tired. It's after school. I'm looking at the red column and not the blue column. I'm not supposed to add or subtract to the transformed x values. I'm supposed to add and subtract from the y value. So in this case, I'm subtracting 3 from the y values. Let's try that again. 9 minus 3 is 6. 4 minus 3 is 1. 1 minus 3 is negative 2. 0 minus 3 is negative 3. 1 minus 3 is negative 2. 4 minus 3 is 1. And 9 minus 3 is 6. So now this is the new x, and this is the new y. So these are the values that we're going to graph. So we're going to graph negative 2, 6. So negative 2, 1, 2, 3, 4, 5, 6. And then we're going to graph negative 4, 1. So I'm sorry, not negative. What did I graph? I don't know. I'm just making up the values. All right, let's look at the right value in the chart. We have negative 5, 6. Let's try this again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Where on, oh, I guess I'm looking at what we're at. I'm tired. I am very tired. Negative 5, 6. Negative 4, 1. I'm going to say these out loud so I don't write the wrong value down. 1, 2, 3, 4, 1. The nice thing is if you do the wrong value, your graph will not look the same. And you will be like, ow, I graphed the wrong points. And then you can just go through them. So you will know you were wrong. Negative 3, negative 2. So 1, 2, 3, negative 2. Negative 2, negative 3. Negative 1, negative 2. 0, 1. And 1, 6. All right, so there's our graph. Notice it is the exact same size and shape within the confines of my drawing. It's just moved down and to the left. Oh, we did not fill in the vertical here. We wrote the g of x minus 3. That was down 3. You can see the vertex right here. So that's the point negative 2, negative 3. But it's also right here. Just remember that that plus is really x minus a negative 2. And then negative 3. So notice that the x-coordinate, so for a parabola, the x-coordinate of the horizontal translation is the x-coordinate of the vertex, and the vertical translation is the y-coordinate of the vertex. So it's really easy to figure out the vertex when you have the graph written like that, the equation written like that. And actually, that form of the equation is called vertex form. The domain, this is a parabola, negative infinity to infinity. And the range, the low value, is negative 3 to infinity. And I think that's the end of this video. Let's see. Oh, no, I'm going to do this page. So I'm going to do this page, and that's that. Okay. All right, so if g of x equals, and this is in your notes, f of x minus 2, how is the graph of f of x translated to form the graph of g of x? Well, the graph is translated. Notice it's not to the x, it's to the whole function. This would be 2 units left, down. Just got a warning on my watch. Danger, thunderstorms. U.S. National Weather Service has issued a severe thunderstorm warning. I better hurry up and finish these recordings. If h of x equals f of x minus 4, notice it's in the parentheses, how is the graph of f of x translated to form the graph of h of x? So in the parentheses, and it's a minus, this is going to be 4 units right. All right, so now we have, and so I want you to add, those two are in your notes, but add these two as well. You just have to write the equation. And then we're doing the same thing. So I of x is equal to f of x plus 3 plus 6. So how is the graph translated? The plus 3, remember this is really f of x minus a negative 3. All right, that is 3 units left. All right, because it's added to the x. And the plus 6 at the end is 6 units up. And then j of x equals f of x minus 3 minus 6. All right, so that x minus 3, the minus goes with the equation, that's really a 3. That is 3 units right. And the 6 at the end is 6 units down. So I want you to put the answers to A and B, and then all of C and D in your notes. Just find a spot for it, hopefully next to A and B. And this is where we're stopping. Oh, yes, I said that. All right, so thanks for watching, and bye for now.